On with this biology exam paper, which is November 2020. Right, let's crack on with it then. Cholesterol is needed in the diet for making cell membranes. State the role of the cell membrane. Right, it is used, or it controls, it is used to control, you can say what goes in and out of a cell, or movement. This is the posh way of saying it, movement of substances in and out of a cell. Right, okay. Too much cholesterol is a health risk because fatty deposits build up in arteries. So remember we said an artery takes blood away from, oh, not a heart, the heart. And veins bring blood back. Hepatic portal vein is the only one that doesn't. Hepatic portal vein back to heart. What do capillaries do? No, I can never spell this silly word. Capillaries. Capillaries take blood through organs. They're very, very fine. Right, let's move on. The lumen is the hole. So there's an artery. This hole in the middle is like a pipe. The bit in the middle is called a lumen. Lumen has a diameter 4 millimeters. Yeah. Before the buildup of fatty deposit. A fatty deposit covers 45% of the original area. So this is what. So we know area of a circle is pi r squared, which is they've told you to use, look, they've told you to use 3.14 times radius of this. Right, look careful, they've given the diameter. The diameter is 4, so we're going to have to do 4.0 divided by 2. That's 2, and then we're going to square it. Which becomes 12.56 millimeters squared. Now they've said that 45% is covered. Now we need to look at what is available. So look, this is what they're saying. That's the area, and if I did an imaginary line there, they're saying just under half is covered with cholesterol. So we've only got this bit where the blood is flowing, which is 55%. So we need to work out 55% of this. So what we do is we do 0.55, because that's 55%, times 12.56. Let me do it here. I can write it as 55% of 12.56, which we can write as 6.9. They've given 6.91, 6.908 square millimeters. So we can get it with any one of those. So this is a maths question. You've just got to pull out the right bit of information here. So let's try that. So what they said is they gave us a diameter of 4, so we know the radius is 2. 45% is covered, so 55% is not covered. So we want 55% of that. They've given the formula for the area and they've given you a value of pi to use. Right, let's move on. Scientists test, right, okay, blood, Right, we need to, let's take this down. Let's take this down. Have I got, yes I have. That's excellent. Can we read that? Okay, good. I think we can get away with that. Plot a suitable graph on the grid to show these results. Right, so what I would do is, I would put that on the x-axis. So look, we've got to pretend, how should we do this? Let's use, then it's easy to see. We've got to pretend it's a straight line. So I'm using a ruler, imaginary ruler. Right, I need to stop being lazy. Oh, goodness me. No, you can't. See, it's snapping to grid, isn't it? It's probably got an option. But anyway, listen. Let's stop messing about. Just crack on with it. Right, I've got a pretend ruler. Drawing it up here. Now, that's the first bit. What I now need to do is put the labels on, because so I can put here range of blood cholesterol concentration, right? And then you put milligrams per centimeter cubed, and then on here we're going to put in number of men in each range. Ooh, that's not good, is it? Number of men in each range. Right, we've done that. So we've got 1, 2, 3, 4, 6, 8. We can put 1, 2, 3, 4, 5, 6, 7. Okay, so we can't do that. So what we'll do is this first one, and we'll just change color, so it'll be 80 to 190. This next one here will be 120 to 159. I've run out of space, but you'd move the label down. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Right, okay. So let me, this is why it's good doing it in pencil, because then you can rub it out like this without killing anything. There you go. So I really need to start here. So 80 to 119. This is 120 to 159, 160 to 199. That'll be 200. That'll be 240, 280, 320, and finally 360. Right, now I've got to be careful with this. So the highest number here is 442, so I need to make sure 100, 200, 300, 450. So I'll just squeeze it in there. Right, so that's 100, 200, 300, 400, 350, 250, 150. Right, okay, and that's 450. Right, now we've got it. That was the easy part. So what is it? Right, you can, it just says suitable graph. Right, you can do line graph, bar graph. So what we'll do is we will do a right. Ah, hmm. Do. Right, where are we? 13. So, oh, 10, 30. This is going to be a bit tricky, this. So, 13's about. Right, and then the next one, so we've done 13, we go to 150 from there to there. 150. That's not, that doesn't stand out, does it? We did it in black. Yeah, that's better. So each one of those 10, 150 straightforward is on the line. It's the ones in between that are going to cause a bit of trouble. So we've done that. 442. 442 is about here. All the way down, straight line. So I'm assuming you've got a ruler. Right. That's that done. 229. It's around 300. They're not going to criticize if you go to 300. So remember that's 200 to 239. This one's 160 to 199. That's, yeah, that's done. Right. 240. So we've done that one. 115. 279. 115. Where's 100? 100's there. 110's there. 115 is halfway between. Right. That's that done. 34. 10, 20, 34. Right. 9. So that's just below that line, which is fair enough. Oh, you're joking if I run out. So I've run out. That's a bit silly. So what I should have done is moved all these that way because I've just run out. Right. I'm going to cheat. Right, I'm going to cheat. Let's get rid of that line. Right, so the other one is 5, so it'll be half of that. So look. So what I'm going to pretend is all of these. I wonder if I can actually. Do you think I can get away with that? Can I cheat that way? Or 50, 442. What if I did this? Oh yeah. Oh yeah. I think I can cheat on that one. There you go. So, well, not really, no. I lie. I can't cheat. Right, so I would shrink these. Right, just bear with me. Right, I've redone that. Because if I tell my students to do it, I have to do it. Right, okay, that's what it looked like. So, right, so it's important just to plan it then before you commit yourself. And always do it in pencil so you can rub it out. Right, let's move on. Which range of blood cholesterol levels is the mode? It's this one here in the middle. Yeah, 160 to 199. So it's 160 to 199. Because that's got the most in it. That's this one here. Got the most people in it. Right. So they want us to calculate a blood cholesterol level greater than 239 per 100 centimeter cubed. You've got high risk of heart disease. Percentage of men who've got more than that. So we look at the table. 239 higher than 239. So that's these. So it doesn't give you how many people. Oh, okay, fair enough. So we'll have to add everything up. So it will be 115 plus 34. So this is how you're working out. And then when you add up, let's use that color. If we add up all of these, that's the total. So if you add up the total, it is 1067. So we do 163 people out of 1067. That's the fraction. And we turn it into percentage and multiplying it by 100. So it's the fraction, that fraction times 100 gives us the percentage, which is 15.276. I would be inclined to round it off 15.28, but they've said anything between 15 and 15.2, no, 15.3. Yeah, that's what they've said. Okay, so it's a simple percentage question. This is why your maths is key to unlocking your science. Right. Statins are drugs that reduce blood cholesterol levels. Scientists investigate the use of statin. Give statin to one group and a control to another group. He calculates the percentage of in each group that have a heart attack in the next 4 years. There you go. So statins 2.2, control 3.8. Conclusion from his data saying that the statins reduce the risk of heart attacks. And now this is where you need to discuss. Look, these questions are coming up more. They just say go ahead, discuss it. 4 marks. There's 4 marks. Right. Statins reduce the number of heart attacks. Right. Right. The fact that is used on a group of people. He's used a group of people, right? Okay. He has used a group of people, so results may be reliable. However, the size of the group was not stated, was not given, so it could be that it could be small. Right, you might need a larger group size. Right, so it's only being tested for a short time, only tested over a short period, because it could lead to other problems. So normally what happens when you take a drug for one thing, one condition, it has side effects, and then you have to end up taking a drug for the side effects. So it's a difficult one, that we don't know the health status, we don't know health status of the participants or the people, because some may have had existing heart or health issues, conditions. Right, there was no data on exercise or diet or lifestyle, for example, alcohol or smoking. Right, there's no data on it just says group of people, it doesn't say males, does it, or females? No data on gender, so it might be more effective on males or females, we don't know. No data on gender, family history of heart attacks, it could be hereditary, of heart disease. So all these, so you can make the statement you've reduced the number of heart attacks, that's obvious, right? As a percentage, it's almost like halved. He's used a group of people, which is good, but they've not stated what size the group was. It could have been small, so you might need a bigger trial group. It's only tested over a short period. You've only tested one type of statin. We don't know the health status of the people. Some may have had existing conditions, so we don't know the health status of the participant. It might have been that you've picked up all the healthy ones, giving them statins. Right, lifestyle is really important. Do they do exercise, diet? Do they smoke? Do they drink? We weren't told the gender, the family history, to see whether that has an effect. Right, okay. We'll do this on the next one. Right, let's stop that there.